We consider here an example where we study the interpretation of the partial derivatives in the context of an application. So if we have a function g of xy, which is the amount of gas sold per week by a gas station, and the inputs x and y are x, our price, and y being the price of a competitor, can we predict what the sign of the partial derivatives dig dx and dig dy are? Well, I think we can using our intuition about the context here. If we're looking at the partial derivative of g with respect to x, remember what this translates to in terms of a sentence. If we increase x, and x is the price at the gas station, which so our price if we're putting ourselves in the shoes of the gas station owner, if x increases, and so we're charging more money for our gas, then it's pretty clear that we expect to sell less under classic economic assumptions here. So reduced sales, and that translates to a decrease in g. So if we take a step in the x direction that's positive, we get a resulting decrease in the function g, and that would tell us that the sign of this partial derivative is negative. Delta g over delta x will be negative because when delta g goes up, delta g is going to be negative. Or when delta x is positive, delta g will be negative. And that's all we have to do to interpret this. We should ask ourselves, is this going to be always true? I think in this scenario it's pretty clear that it is always true, assuming our prices are all positive and things like that. And the other assumption that we've built in is that y is kept fixed. So under the single condition changing of x being increased, then g will decrease. If we mix that with our competitors doing something, it's a whole other thing. Partial derivatives only tell us part of the story, thus the name. So they tell us how g would respond if x alone was changed. What if we compare that with the y derivative? And this should be a partial derivative. So dig dy. Again, we talk about an increase in the input. What happens when y goes up? Well, y is their price, our competitor's price. And if our competitor's price goes up, well, we expect more customers are going to come to our side, so we expect an increase in sales. And since g is our sales, we expect that we're going to see an increase in g. And therefore, we're going to see a sign of that derivative being positive. As we take a step towards higher y values, as our competitors increase their prices, we expect our sales will increase. It won't always be by the same amount, but the direction will be consistent. And that's how we can do a quick interpretation of these kinds of signs. Let's take a look at another example where H is the number of pairs of ski lift tickets sold in a year in Canada. So H is an amount sold, and X is the number of ski boots also sold, and Y is the number of tickets from Canada to some other warmer vacation spot. So how would this play out? Well, if we're interested in knowing what the relationship is, the partial relationship, the partial derivative relationship between H and X, we ask that same question we just did before, which is what happens when X increases? Well, X is more ski boots sold. And if more ski boots are sold, this is a much less direct economic connection, but under most assumptions, and again, there'll be some assumptions built into this analysis, if we're selling more ski boots, that means there's probably more people skiing, and we expect that the ticket sales will increase as well. So an increase in skiers, and no one spends that kind of money on ski boots just to have them sit in the closet. Well, maybe some people do, but it's not your goal when you buy them. So we expect to see an increase in ticket sales, in ski ticket sales. And that is exactly what H is, so an increase in H. And so taking that back to our derivative, we expect this derivative to be positive. Likewise, if we look at the relationship between y and h, when we studied as a partial derivative, we can take a look at what happens when we increase y. If we notice that the number of tickets from Canada to warmer vacation spots goes out, or goes up rather, then this is again a more indirect connection, but economic theory would tell us that people have a choice and there's a limited budget. If they're spending more on tickets to get to warmer places, then they're less likely to go skiing because they have already spent their travel money. And so we'd expect a decrease in ski ticket sales here. Again, this is under some assumptions, but it's a pretty reasonable conclusion. So we expect a decrease in h there. And so this derivative here would be negative overall. And if you're looking for the economic theory terms that go with this, we would call substitutes, we would call the idea of being able to ski or being able to go to somewhere warm as substitutes for one another. They're both entertainment and they'd be both spent out of the same budget in most families. Whereas the ski boots and the ticket sales, those would be complements for one another. It makes no sense to buy one without the other. And so if one type of sale goes up, the other will typically increase as well. So there's some nice economic theory that goes into this description of these partial derivatives.